During recent years, there have been increasing problems with gutters unable to cope with heavy rainfall during storms. And if these are inboard gutters, such as valley and parapet types, this can lead to overflows into the building. It appears that the types of roofs most commonly affected are metal profiled roofs on industrial, commercial and retail buildings, very many of which do have inboard gutters. These metal roof sheets are non-retentive in terms of water absorption and have little frictional resistance that could help slow down water flow. During roof refurbishment programs, it's quite common for problems not previously experienced to occur where fibre or asbestos cement roofing has been changed to metal profiled sheets. This is because fibre cement has water absorption properties, and its surface has a rough finish which provides frictional resistance to the flow of water. The porous nature of the surface encourages mould growth, which also interrupts water flow and further helps frictional resistance. This slows water flow, allowing the gutters and outlets time to discharge. Water retention, frictional resistance and interruptions to the flow of water have been the keys that have helped fibre cement sheets to protect the building from water ingress. And it's these observations that have ultimately led to the development of the UniDam system. UniDam is a rainwater management system designed to control water flow on the roof during heavy storms and to help prevent water ingress into the building. During a heavy storm, rainwater travels downslope at increasing speed and depth, whilst also collecting the precipitation discharging to it. This water, left unchecked, enters the gutter in such volumes that it can overwhelm the drainage capacity of the gutter system, and is the effect that can lead to overflows, particularly when the gutters and outlets may have insufficient coping capacity. UniDam does several things to prevent overflows using a series of blade-like dams. 1. The blades disrupt water flow, decreasing its speed. 2. The blades isolate areas of roof between them, localizing the rainfall and helping to prevent water collection downslope. 3. The blades act as mini-dams that store water, preventing the large volumes from reaching the gutters for a period of time. The water storage imposed load is kept within the design snow loading. 4. The blades allow water to pass beneath at a controlled rate, nominally 75 mm per hour, by virtue of small gaps whose size is determined at the calculation stage and produced during manufacture. 5. UniDam also has water storage duration well in excess of the normal expected storm intensity period of 2 minutes. Storage periods well in excess of 30 minutes are not uncommon. The blades are manufactured from materials that are sympathetic to the original roof and are profiled to suit the roof sheet. The blades comprise two components, the brace angle and the UniDam blade. They are fixed to the rib or upper corrugation of the roof sheet and are fitted continuously along its length and at right angles to the roof downslope. The brace angle is fitted to the roof sheet rib, continuously along the length of the roof in 2.8 metre sections using stainless steel drill screws. Gun mastic seals are applied beneath each fixing position. The UniDam blade is fitted in either 1 metre or 2 metre lengths, depending on circumstances over the brace angle. Small drill screws are applied through pre-punched holes at the rear of the blade, and the front leading edge of the blade is secured with stainless steel drill screws, again sealing beneath each fixing position with gun mastic. UniDam blades are always positioned above end laps and avoiding roof lights and unsealed barge and verge flashings. The water storage width will be a minimum of 300 mm below end laps. Each blade run should be positioned as near as possible to existing purlin runs. It may be prudent to check and if necessary reseal the side laps of the roof sheet as a precaution. The number and size of the blades are determined by calculation using software developed at the testing stage of the product. The UniDam software uses rainfall data from BSEN 12056 Part 3, 2000. By extending the data series from the 2-minute event to longer durations, as per BSEN 12056 Part 3 2000 Annex NB, the software is able to perform a dynamic storage assessment in small time steps to evaluate the maximum water level for any given storm return period. Flow out of the dam is based on physical test data undertaken on a full-scale roof sheet mock-up. A design category can be chosen at the calculation stage, and this is normally Category 2. And the storm return period in this roof store category is 60 years. Each individual roof requires a separate calculation. Input information required is 1. Geographical location. 2. Length of roof. 3. Slope length. 4. Pitch of roof. 5. Valley or eaves roof condition. 6. Gutter and outlet capacities. The gutter and outlet capacities are required to ensure that they can cope with the reduced discharge from the blades, which is based at 75 mm per hour or 0.0208 litres per second per square metre. Gutter and outlet capacities are calculated from information provided at survey. A survey proforma is available to help at this stage. However, it's possible to provide a calculation and budget quotation from Google Earth information, provided that the building can be accurately identified. At the order stage, AMP team personnel will survey the roof of the building to obtain the information required for manufacture. Provided that the gutters and outlets are able to cope with the 75 mm per hour rainfall discharging from the blades, as most systems will or have been corrected to, then the UniDam will provide complete protection within the confines of the design.